So the next problem, chapter 30, out of module 1, 24. A wire is bent into 3 circular segments, each of the radius 10 centimeters, as shown in this figure. Each segment is a quadrant of a circle. AB lying in the XY plane, BC lying in the YZ plane, and YZ plane, and CA lying in the ZX plane. If a uniform magnetic field B points in the positive X direction, what is the magnitude of the EMF developed in the wire when B increases at the rate of 3.0 milliteslas per second? What is the direction of the current in the segment BC? So what we know right away is that this quadrant, the XZ quadrant, and this quadrant, the XY quadrant, we don't have to bother with these because B will come through and it will just skim the surface of these. So there's no B coming directly through this surface at all. So the only quadrant we have to deal with is the ZY quadrant. So this is what it looks like. We have essentially the B field coming through the surface, coming through the ring, not a surface, straight out at us. And we also know that R is equal to 0.1 meters. So first let's solve for the induced voltage, which is D dt phi. And what we know is that this field is changing with time. So I can say, and it's the field that's changing with time. So I'll just say change in the field, changing with time, and phi, and we'll just put the area out here. Now we'll set up, what is the area? Well, the area is equal to pi, and R is 0.01. Square times the change. Now we know that'll be B. We'll just say it started at 0 to what we're interested in. So we won't show the 0 in here. We'll just show B. So B is 3.0 milliteslas second. So that is 3 times 10 to the minus 3 Tesla seconds. So now we can solve, and we're going to divide this by 4 because this is just 1/4 of a circle, so we're going to have to divide this by 4. And when we do the math, we're going to see that E is equal to 2.4 times 10 to the minus 5 volts. So that's what the induced EMF is. Now the other question is, which way does it flow? And I'm just going to refer you back to this figure you're going to need to look at this. When the B field is inside the page, the current is flowing counterclockwise. So we have a situation where the B field is out of the field, so the current is flowing from C to B. So that's the answer to the second part, is flowing from C to B. Learn your right-hand rule so you can figure out which way the current is flowing. And also you have, if I can find it real quick, this aid in the book to help you figure out which way the current is going. So any trick that you can learn that's consistent, use it to figure out which way the current is flowing when we're inducing a voltage. That solves this problem.